We are in week 4 now, talking about big data. And big data is actually what makes the whole notion of data science a reality. The whole idea of analytics, data analytics, wouldn't be possible without big data being present. And most of us think of big data as huge server farms, huge buildings full of all kinds of large server devices. Look something like that. There's a lot of myths surrounding big data and a lot of things that are both myth and fact. Uh, the idea that big data is new is both true and a myth in a lot of ways. It has been growing in a way that we didn't really realize until well after the fact. But big data has been around for decades now in one form or another. It's just gotten a lot bigger. It is not only about massive volume, it's about uh, accuracy and mining the data to help your business improve the performance of your product, improve your approach to your markets, improve the way you handle personnel. It's about just about every possible facet of an organization because the organization's essence and its information lives in the data. Big data means Hadoop. Hadoop is a way of bringing all these servers and all these databases together. It enables huge scaling that means that you can have your enterprise connected to the literally thousands of servers and all kinds of databases for operationals. Big data need a data warehouse. In a lot of cases, this is true, so it's not necessarily a myth. We're going to talk about data warehouse in a little bit here. Big data means unstructured data. It means both unstructured data and structured data, actually. But it's, I guess, a myth that it's all about unstructured data. Big data is for social media and sentiment analysis. That's sort of might sound glib, but that's what a lot of people think that data is about uh, judging political or social attitudes based on uh, things that are out in the public domain. Big data is a lot deeper than that, obviously. We talked about this at the beginning of the class in terms of huge volume, so I'm not going to dwell on this. You can always pause and look at those facts and figures there, but it just gives you some of the I guess, reinforcement for what we've been talking about in terms of all the things we have that are generating all this data. And here's another one that you can look back on. New York Stock Exchange, 1 terabyte of data every day, that thing down toward the bottom. It's a lot. Everything we do generates data. One of our articles talked about how, I don't know, 1 second of a jet engine running generated just an unfathomable amount of data. So this again, a slide that you can reflect on your own in terms of the words that are associated with data and data handling are generally volume and velocity, variety and veracity. So there again, one that you can look at on your own, but those are some of the key points about data and ultimately about how we use it, how we build analytics to make the most of it, and how we interpret or analyze those analytics. Cost efficiently processing the volume, that's a key consideration. Responding to the increasing velocity, usually that means hardware and improved technology. Collecting and analyzing and broadening the variety. 80% of the world's data is unstructured, but there's so much data that 20% that is structured is highly significant in itself. And then again, establishing the veracity of big data sources. As it said on the other slide, 1 in 3 business leaders don't trust information they get to use to make their decisions. Pretty significant, right? But what is really important about all this data is something that was reflected in one of our readings this week. I think it was the the beyond the hype reading that we took a look at. Companies need to be able to choose the right data and manage multiple data sources. They need to have the capability to turn it around and turn it into insights. We know what insights are, right? Uh, that's what you gain from the combination of the right data and an effective analytical approach. You get the ability to have those insights. It doesn't come automatically, but it kind of gets you in the field where you can do that. And management needs to undertake a change program so that insights yield better decisions and translate into effective frontline action, which kind of gets us to the wisdom point in the pyramid we looked at a couple weeks ago, right? All this kind of circles back to the whole DIKW notion. Data, information, knowledge, wisdom. So we are kind of in the frontier now with data. Other aspects of big data. Automating research will change the definition of knowledge. It's going to continue to change. We have to be aware of that. Claims to objectivity and accuracy are misleading. Maybe not intentionally, but because we on our side are human beings. We have our own subjectivity, our own interpretation. You can take two different managers given the same analytics, and one manager will come up with a different way to approach a problem or take advantage of an opportunity. Not all data are equivalent. Bigger data is not always better data. That's important too. We as people get impressed with numbers and speeds and feeds and that sort of thing. It's a quality sample that's smaller is better than a large sample that is not taken from reliable sources. Just because data is accessible doesn't mean it's ethical. So I guess that means we don't necessarily want to take advantage of all the data opportunities that we have. The thing that calls to mind for me anyway is the idea of the Patriot Act and telephone surveillance, which was being done in order to protect the country, or I guess it wasn't actual surveillance, but it was the ability given to the government by AT&T, Verizon, companies like that, as part of our response to 9/11 years ago. And another consideration is limited access to big data creates new digital divides. Some questions surrounding big data. What happens in a world of radical transparency with data widely available? That kind of goes to the last slide a little bit in terms of how much more is the world, as management, as leadership, as organizational structure going to change as the morass of data continues to grow? If you could test all your decisions, how would that change the way you compete? My gut instinct is that it would slow people down a lot. I mean, if you could actually basically analyze and perform analytics on everything you did, you might not get out of your own way. Just my thoughts. How would your business change if you use big data for widespread real-time customization? Might be a benefit in a lot of ways on that point. How can big data augment or even replace management? In a lot of ways, I think it is, and it does. I think one of the things it does is it gives us a little more accuracy. I think it eliminates some of the drudgery, and it can eliminate a bit of the uncertainty too, I believe. Can you create a new business model based on data? Of course you can, in one sense, in that there are all kinds of companies and organizations being built to service the use of data in the data arena. But on the other hand, I think what this question points to is imagine your own company, your own organization. Could you create a new business model for that based on data? A little bit misleading now that I look at this question. It should be, could you create a business model based on the power of data analytics would probably be a better way to frame that. So where do we put all this data that we create from transactions, from at the point of sale to daily practices in finance, accounting, servicing customers in other ways, the operations of the products we make, from jet engines aforementioned to the things we request of Amazon via our Alexa devices. Where does all that data go? My smart aleck answer here is it goes in a warehouse, of course, which brings us to the subject of data warehouses. What is a data warehouse? The term warehouse makes us all think of where the tractors and where the inventory are stored, right? Well, in the case of a data warehouse, that's in a way quite inaccurate, but you can kind of see where the term comes from. A data warehouse, as one of the video points out, one of the videos we watched this week makes clear, is actually a database itself. It's really kind of, in my way of thinking, a super interconnected database of databases of databases. And it's held together by various systems from Apache and those sorts of providers that really enable continual scaling up, because a company's needs for data seem in this day and age to ever and ever increase. A lot of has obviously been taken to the cloud, but the cloud, there's no such thing as the cloud. The cloud is really accessed in a way we would access things from a cloud, but a cloud is really underpinned by voluminous amounts of hardware. But it is nonetheless a physical repository in that it is a base where data, as the one video points out, a copy of all your data is moved to the data warehouse once it is out of the OLTP process, which is the online transaction processing part of it. It's now more in an OLAP setting, online analytical processing is what that's short for. It collects integrated subject-oriented databases within the data warehouse that support decision support systems, where each unit of data is non-volatile and relevant to some moment in time. That term non-volatile sounds a little off-putting, and you think of chemicals and fires and stuff like that, right? Well, what it really means is that since the data is past the transaction process point, it's not volatile. It's not going to change. It's a sale that was made and completed days or weeks ago. It's a unit that was done and expended at a certain point in time. So there's nothing that's going to change about that kind of data. That's what the term non-volatile means. For a historical perspective, I'll let you take a look at this slide. I'm not going to go through the bullets. You can pause now and look at that timeline associated with some of those technologies and concepts. Okay, end of pause. But those kind of give you the critical timeline for the development of big data and the notion of needing data warehousing. Characteristics of data in a data warehouse and the data warehouse itself are they are subject oriented. Everything is integrated. There's time variance. Time variance is important too, because basically every study, every analytical process, every use for data from an evaluative standpoint is going to be looking at times when things took place. So the data is pinned to times and dates at all points. It's non-volatile. We talked about volatility a minute ago. It's summarized. It's not normalized. Normalization is what occurs when databases are put in relational tables more on the transaction processing end. There's metadata with the data. Metadata is, I guess, data that explains data. One example of this is if you ever look at a picture file of a photo you took, it might have other information about the kind of camera that was used, the time, where the picture was taken, if it's from like a smartphone camera. That's all metadata. It is information about the data point or the bit of data that you're talking about. Can be web-based, very dimensional, generally in a client-server kind of relationship, and real-time access when needed by the user. These are all characteristics of data warehouses. Another thing to consider is the notion of data marts. These are small data warehouses, which are really part of the larger data warehouse. A data mart might be attached to an accounting department or finance. These are the types of things that dependent and independent data marts are used for. I really like this slide here. It's nice because it gives you kind of the flow. To the left there, you see all the sources of data that any organization will have, from the enterprise, legacy systems, point of sale transactions, stuff that happens at a counter or at a reception desk, or incoming call volume, transaction volume via the web. All that kind of stuff is the data sources that an organization runs on and that an organization needs to ultimately capture as data. ETL basically stands for extract, transform, and load. Those are the processes of doing the modifications that need to be done to make the OLTP data into OLAP. In other words, changing the data from transactional in nature to analytical in nature, or in how it can be used. It's the same data, the same information. It just needs some transformation, and that's what happens there. There, in the very center there, you see the enterprise data warehouse, and metadata is represented on top. This thing below is replication. All data warehouses have safe replication in case of disaster, fire, systems go down, the grid goes down. There are generally multiple redundancies because basically the data is the company's lifeblood. Just to the right of that, you see the different ways that a data warehouse is parsed out or divided up for slightly different uses. You see different data marts available for the analytical needs of different purposes. And far to the right there, you see the basic ways we use it in analyzing, and these kind of represent transactional things too. It almost goes full circle when you think about it. But in the case of the right side here, these represent analytical uses of the terminals and the computers and the tablets and the laptops. Here's a web-based data warehouse architecture, and a lot of data warehousing is done through, as I mentioned the minute or two ago when I mentioned the cloud. The cloud is really, there's no cloud up there holding data. It's all servers, but we access like it's from the heavens, right? Anyway, so there are a lot of cloud-based data warehouse solutions, meaning essentially that not every business needs to have a server farm to have its data warehouse. I guess that's the important thing. In fact, most don't. Architecture selection factors for those, and this is something hopefully none of us ever have to do, but if we need to design an architecture for a data warehouse, these are some of the 10 most important considerations. Information independence, what upper management needs, the urgency of the need. If you can grow it and build it slower, the better, because you know how the nature of the way your company is going to change. Uh, Nature of end user tasks, how it's going to be used. What are your analytical needs going to be? I think is probably what that means there. Constraints on resources, uh, your view of your system, your company, almost like a SWOT analysis, only applied at a micro level to warehousing of data. Compatibility with existing systems, in-house staff competencies, technical issues, social political factors. There are probably a number of others, but these are the 10 that are most frequently listed. Hosted data warehouses. These are, as I was referring to, kind of cloud solutions. You don't have to make a big infrastructure investment this way. Frees up in-house system capacity. You can keep your cash flowing because you don't have it invested in a lot of expensive hardware and expensive software from, I don't know who you, I want to say Cisco, but I think that's more of a hardware solution. It'll come to me. Powerful solutions are available that help you grow. And really, when you're buying a hosted solution, you're working with a company that's continually upgrading their equipment so that their service can be the best and fastest. You might have a tendency with your own hosted solution to try to patch up the stuff that you've already depreciated fully and keep it going. So there are some technology advantages to using hosted solutions. Multidimensionality is important too. It's the ability to organize and present and make analysis or analytics available by multiple dimensions like sales by region, product, salesperson, time. Uh, the three main dimensions are probably in terms of your product, what you make, your market, and probably your business units. But uh, so you want to be able to look at these things not only by the dimensions but by measures, uh, people, personnel, numbers, money are all different measures, and then time, daily, weekly, quarterly, yearly, by the second, by the fraction of a second. Those are three key ways to look at and need to be able to delineate your data. We talked about OLTP and OLAP. I will let you guys reflect on this slide on your own time if you care to. Again, OLTP is transactional. Those databases and those data processes are very quick, and they're very much related to what is happening now. Eventually, through the process that we saw a few slides ago, it becomes OLAP data. In other words, it is less fast to access, but over time it gives companies a wealth of information for analytical purposes. OLAP operations, that's the analytical side. Here are some key terms: slice, dice, drill down, drill up, roll up, and pivot. Kind of sounds like an exercise in a way, doesn't it? But when you read through these, you see that they are just basic ways of parsing or looking at data or data groups. So take a look at that on your own time if you care to. I've just kind of given you a broad view of it there. We have all kinds of implementation issues, more than could possibly fill this slide, or way more than I would want to put on this slide, rather. Identification of data sources. Does every single data thing a company does need to go into the warehouse? That's a good question, and one that a lot of companies answer no to, right? Data quality planning, data model design, your ETL tool selection. That's the process, remember, of getting it from the transactional data, the point of sale, your enterprise, your call center stuff, All that has to go to the warehouse via ETL tools. Service level agreements. How are you going to use it? Are you going to use the data that often for analytical purposes? That's a good question when you're establishing agreements. Transaction support, data support and conversion rather, reconciliation. How are you going to be supported? Political issues is kind of within the company more than political was probably not the correct term there, but political / management / worker morale would probably be a better way to frame that one. Obviously, there's things to avoid, mindsets to avoid. You don't want to set expectations that can't be met. You don't want to be naive about the process. You don't want to tell people this is going to solve all our company's problems, or once we have these solutions in place, you will be able to know exactly how to crush the competition through analytics. That's not what data analytics is all about. You don't want to load the warehouse with information just because it's available. Again, there needs to be some editing, and that's part of what happens in that ETL process. And by editing, I mean deciding what is going to be worthy data of that can be put in a data warehousing database. Choosing a manager who is technically oriented rather than user oriented, and that I think you guys can understand that. Some people are very into the nitty gritty and the nuts and bolts of and the technology and the hardware that are available, because the stuff's always getting better. It's always getting better and faster, but you want to have managers for data warehouse operations, or you want to select a provider that is more user oriented. And failure factors. You could take this slide and basically take any subject, now that I look at it, and apply it to any business discipline. Lack of executive sponsorship, unclear business objectives, ignoring cultural issues, change management. Heck, I could apply this to the failure of a lot of marketing programs. Unrealistic expectation, inappropriate architecture, low quality or missing information. That's probably the one thing that you can't necessarily say this could apply to any business endeavor. Data quality is a key issue. And also this final one is probably one that is germane to data analytics. You don't want to load data just because it's available. And I mentioned this in a few previous slides. What's really important, though, for this whole notion of big data and data warehousing is that there are 3 core areas that really matter. Improving your decision making, making your operations work on an improved basis, and being able to monetize the data. You don't monetize the data, but you monetize your insights by having the data. And that's from Bernard Marr. He's the author of one of our articles this week. That's all for this one.